I'm Marta. I'm a product manager at Materialize, and today I'm going to do a quick walkthrough, giving you an overview of the change data capture ecosystem. So I assume most of you are familiar with the concept of change data capture, but just throwing a quick recap in here for those who aren't. The basic behind CDC is basically to reflect any changes that happen in your operational databases to other systems downstream. And that can be with the goal of running analytics or building business automation or simply offloading workloads that require a different type of system to run. And there's a couple of ways you can go about it, but I'll just mention the two most common ones. If you, like me, come from the batch world, query-based CDC is probably the first thing you got to know. And in this type of CDC, you periodically pull the database for the latest changes. And this has some very obvious downsides. So the most obvious ones being that you're likely to miss anything that happens in your database when you're not actually querying it. And you're also walking a very fine line and risk overloading your operational data warehouse database with workloads it was never really meant to support in the first place. So the good news is that most databases have an immutable log that keeps track of everything that goes on in your database, like CRUD operations or schema changes. In Postgres, this is called the write-ahead log. In MySQL, it's the bin log. You get the drift. Each database has their own thing. So instead of periodically pulling your database, what you can do is read this transaction log to capture all the changes in near real time. And this has the advantage of you don't really miss things like deletes, for example, which you can capture in query-based CDC. And you get the advantage of having like a push system instead of a pull system, which enables much more interesting use cases. There isn't a right or wrong way to do it, but today we're going to focus on log-based CDC. And to understand where we are today with log-based CDC, it's worth to look at how it all started. I couldn't really find this timeline documented in one place, so I just threw a timeline together in the slides. So like most tools that we're all using today in streaming, the first CDC systems were developed at internet scale companies. It's the first evidence I could find of a CDC system being written about publicly was for LinkedIn. They open sourced their internal CDC platform in 2013. This was not long after they actually put Kafka out into the world, just a few years before. And their main motivation to develop the system was to use the transaction log to avoid dual writes and guarantee consistency as they were replicating changes from their operational databases to multiple consumers downstream, and they wanted to do this in real time. In the same year, Facebook and Stripe also wrote about their own internal systems, Wormhole and MoSQL. And same motivation focused on just improving cache consistency, reducing end-to-end latency for their internal analytics pipelines. And a couple of years later, Zendesk open sourced Maxwell, which is specific to MySQL. And I think it was the first system that could also send data to different streaming systems, so they could write to Kafka, Kinesis, and other systems. I'm always surprised to see Maxwell is still around today. There are still people using it in production, which is really curious to me. So if anyone is using it, I would love to understand how come it's still around. And yeah, that year there was also a really cool talk by Martin Kleppmann. He worked on what I think was the first Postgres CDC system, using what was just released in that year, the support for logical decoding in Postgres. And Debezium didn't release 0.1 until 2016, but from then on, you kind of know how it goes. Probably a lot of people here use Debezium in production today. So, and if it's any indication of how successful Debezium was even back in these days, Yelp released their own MySQL replication platform around the same time. And they ended up archiving their repo and just telling everyone to just move over to Debezium. And after the initial Debezium release, and until Debezium came out with 1.0 in 2020, there were only 2 other projects that I could find that came out. One of them from Airbnb, Spinal Tap, and then DBlog. Probably a lot of you have heard about that one from Netflix. But both were focused on working around very specific needs of serving CDC at FANG scale. But DBlog would inspire Debezium and then some other CDC tools that support incremental snapshots. It's a really interesting paper. I linked all the papers here if you want to drink some tea during the weekend and read papers about CDC. But we only have 10 minutes, so moving on. And all this to say that as data engineers, we mostly agreed that Debezium is the standard for log-based CDC. It has a really big and active community behind it, and that explains why it has the largest number of connectors of any other tool out there. And it's also been used reliably in production at pretty much all internet scale companies for many years. And you can see just at these conferences, every year you always hear someone presenting a use case using Debezium. But like any other tool, it also has its limitations and rough edges. And these have mostly to do with the consistency guarantees it provides or it doesn't provide. So for Materialize, for example, having to deal with at least once delivery forces us to perform very expensive computations downstream to make sure we can serve correct and consistent results. And it's also still not trivial to handle schema evolution or transactional consistency, which require writing some custom logic using some obscure sidecar topics that Debezium makes available. But for most use cases and the average user, the good likely outweighs the less good because a lot of people are using Debezium. So let's see what other people are building with and without Debezium. So starting with systems that are same, but different to Debezium. Every time someone asks me if I heard about this new CDC tool, my first instinct is always to just go and check if it actually just uses Debezium under the hood. And most of the times it does. It's just the Debezium engine wrapped in some UI. So even though a bunch of vendors like to tell you that you need Kafka and Kafka Connect to run Debezium, so you should buy their tool, this isn't entirely true. You can embed Debezium in your applications using the Debezium engine. You can use the Debezium server also to write to targets that are not Kafka. So I just wanted to bust this myth because I think a lot of people don't know these things exist, but they do. So the first class of tools that uses Debezium to abstract some complexity of operating multiple systems or writing and maintaining the code yourself. And because this means that these tools don't really have to build connectors for each different database, it also means that they can spend some time enabling the harder beats of making things like schema evolution work or making connectors that respect upstream transaction boundaries to improve correctness. And some examples of tools like that rely on Debezium under the hood are StreamCap, and then a lot of the streaming frameworks that have CDC connectors like Flink or Confluent Cloud or Rising Wave are also using the Debezium engine. And the second class of tools is tools that are building CDC from scratch or almost from scratch, which is the class I'm most excited about. Not because it doesn't use Debezium, but because it tries to use the lessons learned from Debezium to build more approachable products. And regardless of the level of expertise of streaming we have in this room, it's not true for everyone. And you can see that companies like Fivetran or Databricks or Snowflake, which are traditionally batch-oriented, are also now starting to invest in CDC companies. I would recommend checking out Supermetal, which is a company that is still in stealth, but I'm really excited about what they're building. They are very focused on performance, but also like consistency and correctness. And I think they are the first CDC tool to use Arrow for data transfer, which also makes things like type conversion a little saner than Debezium does. And two other tools that are also cool and that you can check out that are building their own thing are RD and Estuary. RD forks Debezium, but they're building a bunch of stuff on top. I think they have their own snapshotting algorithm. And Estuary just has like a whole batch unified streaming engine that they also built themselves. And I think I'm out of time. I had just like a small demo, non-demo of how CDC works for Materialize, because we built some of our own native CDC connectors. It's all just SQL. So if all you need is a Postgres instance, for example, and a Materialize instance, and as long as you have logical replication enabled in Postgres, you can see that you can easily just snapshot the data into Materialize. And if you pre-create something like a materialized view that computes an average, for example, you can then see that on the Postgres side, you can just insert new data, and it's automatically replicated and incrementally computed in Materialize. And yeah, so I don't think Debezium is going anywhere, but I think that there's more of the ecosystem to explore, and yeah, I'm excited to see where things go from here. Thank you.